In this tutorial we are going to explain the Tickle scripting language, which is the tool command language, or TCL, which we call Tickle. Tickle in Capsim allows you to really script the simulation. You can manipulate the block diagram directly from the Tickle script. You change parameters through the Tickle script and actually run simulations, and also gather data back from the simulation in terms of Tickle variables, collect them, tabulate them, plot them, and do many other things. It's one of the most powerful features in Capsim. In order to use the Tickle script in the graphics mode, you open Capsim by command line typing /capsim-c. So the -c option allows you to open Capsim with both the graphical and also Tickle scripting capability. In the window that you observe, this is actually the Tickle script that you see, and that's the Tickle prompt. In fact, one Tickle command is clear. That will clear the screen. Tickle can be used to load the Capsim topology, or you can actually load the topology from the pull-down menu. In this case, we're going to load tutorial number 6 from before, and we are going to replace the add noise block by another block, in particular the set signal-to-noise ratio block, set SNR. This block comes in very handy. It has a number of parameters. One of the parameters is the actual SNR, signal-to-noise ratio. This block is very powerful. It actually collects data and measures the signal power and adds the appropriate noise in order to meet the specified signal-to-noise ratio parameter. The preamble is an area which it actually uses to measure the actual signal power, and then the next parameter is a window in which it adds noise. The key thing for us to realize is that we can specify the signal-to-noise ratio, and we can specify the preamble. We're going to set the preamble to 128 and the window size to 64, since we're talking about 8 samples per baud, or 8 samples per symbol. Let's go ahead and apply that, and we're going to save this topology as tutorial Tickle SNR. Now we can actually manipulate this block diagram right from the Tickle script. One command that is very useful is display all. And what we see is an actual display of all the topology, every block, its parameters, and also the connections. So here we have all the connections that are highlighted in the graphical block diagram, also in text mode, with every block indicated what port is connected to the port for the other block, etc. Right from the Tickle script, we can actually do some useful things. If we run this simulation, I can actually run it from the Tickle script by typing run. So if I say run, it's actually going to run the simulation. This simulation was a big one. We simulated 100,000 bits, and we actually have 2 plots in the time domain. We're going to get rid of those, and you can actually see the eye diagram. This eye diagram corresponds to a SNR of 20 dB. Okay, there's a command in the Tickle script where you say to name the block, which in this case is set SNR 0. It'll actually go to that block, and then you can type in get info, and you will get a nice print of information about that particular block, and especially its parameters, like the SNR in this case is 20 dB. Also, what inputs and outputs are connected to the block and the block name, etc. Let's go ahead, and one of the things we want to do is from the Tickle script do 2 things. One is we want to go to the actual plots. One of them is plot 0, so we'll go to that block. A very powerful command is param by name. So once you go to a block with the to command, you can use param by name, name the parameter, which in this case is control, and we're going to set it to 0. This will actually turn off one of the plots. The other plot was x plot 0. Let's go ahead, go to that block and turn it off. So we've turned off the two plots, one of the actual decoded bits and the other one, of course, the actual data after filtering. So we've turned those off. Let's go ahead and run the simulation again. Notice that the two plots don't appear and only the eye diagram appears. Let's go back to the Tickle Scripting capability and go to the set SNR block. And let's go ahead and do param by name again. In this case SNR, and we are going to actually set the SNR to a value of 10. Let's go ahead and run the simulation again and see what effect that has on the eye. Obviously we decrease the signal-noise ratio and the eye closes up a little bit, indicating the higher noise. Let's go ahead and get rid of these plots. Notice we're simulating quite a large number of bits, and the simulation speed is quite fast. We can actually go to the B data block, and actually in that block, if we say get info, we see that the parameter for that block indicates that the total number of samples to output is 10,000 right over here. Now, what we're going to do is illustrate a number of other powerful features of the Tickle script. And to do that, I'm going to show you a actual Tickle script, a full Tickle script, which is going to load the topology and change the number of bits, change the SNR, and once the bit error rate has been computed, it will get that parameter from the block diagram simulation and bring it into Tickle and store it in a list, create a table of bit error rates versus SNR, store that in a file, and finally plot the results. So let's go ahead and take a look at that script. Here we have a window which actually shows the script. We're actually using kwrite under Unix KDE utility, very useful, and also a great editor, and also it colorizes everything. We have some comments here on the Tickle script. The first thing we do is type new. New actually cleans out the previous topology. We're setting up two lists. One is the signal-noise ratio and one is the bits. Notice that for different signal-to-noise ratios, we want to simulate different number of bits. Because if the signal-to-noise ratio is low, we don't have to generate a lot of bits in order to get an accurate bit error rate estimation, because you're going to have a lot more errors. But as the signal-to-noise ratio goes up, errors are rare, and we need to simulate much more points. Like in this case, we're simulating roughly 1 million bits. So in Tickle, it's very convenient to set up two lists. One is SNR, one is bits, and they're coupled to each other in this way. The command to actually load the topology is cap load, and we name the topology, the same one we used to open using the pull-down menu. And here we're going to turn off the plots. Once we've loaded the topology, we can actually go to the block and using param by name, turn that block off. In this case, these are probe blocks that plot data, and we're going to tell it to just pass the data through and don't plot it. We're also going to go to the eye diagram and actually delete that. And with the delete command, the eye diagram block is actually deleted, but the connections are repaired. So if we go back to the topology, what's going to happen is this eye diagram is going to be deleted, but this connection is going to be repaired. It's going to be, this block is directly connected to the demultiplexer. The reason we're doing that is, of course, since we're simulating many points, we don't want to slow things down by plotting the eye diagram. As we go through this script, we create an empty list in Tickle called bit error rate results, and it's empty. And what we're going to do is for every simulation that we run, we are going to get the signal-to-noise ratio and the simulated the bit error rate obtained by simulation and put those into this list and create a table of bit error rate versus signal to noise ratio. So we use the for each command, and essentially what we're doing is for each SNR val, if we go back up here, we see our list. We have a list for SNR, we have a list for bits. For every value in SNR, we get a value out, SNR val, which to begin with is going to be -2 for the first time. And for every bits, the list in the bits, we're going to get number of bits. In this case, it's going to be 10,000. So we're going to go through this whole iteration down to here, and let's see what we're going to do. Essentially, for each iteration, we're going to go to the binary data generator and use the command param by name, specify the parameter, which is number of samples, which in our case is actually number of bits, and replace it with a number of bits that we get from this list, which, as you recall, is actually this number here. So for -2 and 10,000, we specify the number of bits to be 10,000 for the B data block. We go to the set signal to noise ratio block, use the param by name again, set the SNR, which is the name of the parameter, to SNR val, which is derived from the list. And then key command is we run the simulation. After we run the simulation, the block error count file append, let's go back to the block diagram. This block here actually has the capability to store, once a simulation is done, once the bit error rate has been estimated, it would actually store that in a Tickle variable that is then available to the Tickle script. The variable is going to be documented in the star or block's source code. It is documented in the block's source code. And in our case, it is going to be the name of the block with an underscore BER. So we can uniquely identify the variable, which is the bit error rate estimation, and extract that. So this is very interesting. So if you look at this command right here, we are actually going to print that out to the screen. We're going to print the signal to noise ratio value. We're going to print the number of bits. And for that signal to noise ratio and that number of bits that were simulated, we are going to actually print the bit error rate estimate, which is actually this variable, which is eCount fab0 underscore BER, which was produced by that block at the end of the simulation. So this is very interesting. You can interact with the block diagram and get the results, bring them back into the Tickle script, and manipulate them or do whatever you want with them. In this case, we're going to collect the bit error rate versus SNR in a table, in a list, and later store it in a file and plot it. So in this command, list append, which is a built-in Tickle command, we take the bit error rate results, which is the list, the bit error rate results list, and we're going to append this list, which is the actual coupled, the signal noise ratio value and the estimated bit error rate from the simulation, which is from the eCount block. So this will iterate for as many points as we have in these two lists. So very easy to set up. Once the simulation has been completed, we go ahead and open up a file called biterrorrate.dat. We set it up for write. We create a file handle. And notice that once we create an empty list up here and we append things, the first item in the list is actually empty. So we create a control variable called I. And when I is 0, we're in the first iteration and we just throw away that first line. And here we're just going to basically not write that to the file, which is empty, an empty part of the list, and write the following items, which are all the tabulated bit error rate versus SNR. And this is simple command, put string. We don't want a new line. Here's the file handle. This is basically for each value in the list, get the first value, which happens to be the signal noise ratio, then get the next value, which happens to be the estimated bit error rate, store it in the file, set I equal to 1, so we don't skip, and keep storing those for how many items we have in this bit error rate list. So this actually stores the results in a file. And here we close the file. Very simple. And the following, we do the same thing, except we just print it to the screen. So immediately we have the results. Once we have the results in a file, here we are going to illustrate some of the very useful commands in the Tickle script that are provided with Capsim. And these have to do with creating curves and plots. To create a plot from a file, we specify actually that this is a double column file. So the curve double column file, specify the file, which is bit error rate, which we actually created. Notice that that was the file that we stored. So we create a plot based on that. We're going to set the y-axis to be logarithmic. We're going to set the x-axis to use fixed instead of scientific. And notice that once we open a file for a plot, we can refer to that plot that's actually going to appear on the screen through Tickle variables that are passed to the Tickle environment. And of course, whenever you use a dot in the file name, that would be replaced with an underscore, and usually it's reported directly to the screen, so you know exactly what that plot's variable is, so you can do some further manipulations or edit on that plot. So we're going to set the y-axis to logarithmic. We're going to set the x-axis to use fixed instead of scientific. We are going to label the x label as SNR, the y label as bit error rate, and we're going to change the title of the curve to bit error rate versus SNR for baseband digital. We're going to turn the grid on, and then once we've applied all these commands, we're going to tell the plot to redraw itself to reflect those. So here we've gone through a Tickle script that illustrates iterative simulations, how to collect data, run simulations, change parameters, run simulations, collect the data, tabulate them, store them in a file, retrieve that data in a plot, and actually plot them and edit the plot in the meantime. So let's go ahead and do this. So here we have the script. We're actually going to run it. To run the script, we type source TCL, actually the name of the Tickle script. In this case, it is going to be ber.tickle, which is this script that we've described. So once I hit return, it's actually going to start the simulation and present results as we are generating the results through each iteration of the simulation. Here we go. So it's actually gone through a number of signal-to-noise ratios. These symbol errors are being reported. These are actual errors that are happening. Now, of course, the signal-noise ratio is 4, so the errors are much more rare. And finally, we get the plot. So the simulation was done. Here we get a table printed out, which is the SNR and the bit error rate for that particular SNR. And here we have an actual plot of the results, in which we have the bit error rate versus the signal-noise ratio. Notice the title. We turn the grids on. Notice that x is fixed and y is logarithmic. So we have demonstrated how to use a Tickle scripting capability actually in Capsim in order to do iterative simulations. This is extremely powerful in automating many operations and running simulations and doing optimizations, changing parameters over intervals, running many simulations, gathering data, finding optimal solutions, optimal designs. This is an extremely powerful capability in Capsim using the Tickle command, which is stands for the tool command language. Very standard within the electronics industry. And we, of course, have added many commands of this. And in Capsim, you can actually extend Tickle yourself and add many more commands beyond the commands that we provide. This concludes the tutorial on the simulation of a digital communication link in Capsim, and also and how to write a Tickle script in order to do iterative simulations to generate a bit error rate versus signal-to-noise ratio. And in future tutorials, we will even dive deeper into Tickle scripting.